This section of the lecture corresponds with section 6.6 of the Revel text, and it's really critical that you move through what Revel has to give you with confidence intervals. There's only so much that I can describe verbally about confidence intervals. You need to see how to manipulate these data in order to arrive at the confidence interval. But a confidence interval is essentially a way to define a margin of error around a mean estimate. So if we want to, remember what we want to do with statistics is estimate population parameters. We do that by collecting data from samples and computing statistics. So I might compute a mean value from a production line in terms of the amount of time it takes them to assemble a final product. And I want to use that sample average as an estimate of what might be going on in the entire plant. And that's very risky to just place that kind of a judgment on a single value. And so the confidence interval is meant to give us a kind of margin of error within which we'd expect to find the population mean a certain number of times. So we compute confidence intervals around a sample mean so that we can have a range of values that we can be, 95% confident that the true population mean will fall. And so we can have confidence intervals at various levels. So I'm going to discuss 95% confidence intervals and 99% confidence intervals. But you should understand that two things. First, the percent confidence interval corresponds with the error rate. So if I have a 95% confidence interval, I have a 5% error rate. Likewise, if I have a 99% confidence interval, I have a 1% error rate. And so these things are kind of zero sum. The more confident I am, the less likely I am to have error. There's no such thing as a 100% confidence level, just in case anyone is wondering about that. And number two, confidence intervals gives us an idea of what we'd expect to find across repeated sampling. Anytime we do a single study, we run an error of placing too much confidence in that one study. And so putting a confidence interval around the effects found in those studies will give us kind of some cushion of a margin of error against which we can interpret our findings. So in order to arrive at the values that you need to compute the standard error, to compute the confidence interval, what you need is a sample mean. You need a standard error, which you can compute if you have the population standard deviation and the sample size. And then you need standard errors. The book calls them standard errors. I call them Z critical values. These are table A, which we've dealt with in the last chapter. And this tells us that a 1.96 standard errors covers 95% of sample means, giving us 2.5% in each tail. Now, if you haven't read the book, this lecture is not going to make sense to you. So you need to spend some time working through the information that's contained in the Revel text. Just to show you what this looks like, if I have a distribution of scores and I have a mean of 232, if I want to put a 95% confidence interval around that part, I want a margin of error, which means that I'm talking about a lower level and an upper level. If I have a 95% confidence interval, I divide that area into the top and the bottom tail of the distribution. That corresponds with 2.5% in the tail on each positive and negative end. And then, as I've just discussed, the standard errors appropriate for 2.5% are 1.96 in either direction. Those 1.96 standard errors puts 95% of the distribution in this white non-shaded area and 5% of the distribution divided among the top. So I arrive at the standard errors for those values, and then I can convert those standard errors to x, two values of x. And this is detailed in the Revel text how this is done. But in this way, I can arrive at the range of possible values that I'd expect to find across repeated sampling if the null hypothesis is true, or if, in fact, the sample is representative of the population. And so these values in this case would be 219.54 to 244.46. Conceptually, we can think of the confidence intervals as margin of errors as we're trying to make estimates of our population mean?